Hello everyone, welcome back to my channel Learn with DevOps Engineer. If you are new to my channel, please don't forget to like, share and subscribe for more DevOps tips. Today, we are going to explore two key technologies used in DevOps, Docker and virtual machines. Both are crucial for isolating environments and running applications, but they do this in very different ways. Let's start with virtual machines. A VM is essentially a software version of a physical computer. Here's how it works. I'm going to draw a box now and I will try to explain step by step. So this is a box. In this box, I'm going to draw a small rectangle box and I will try to add some text in this box. So this is the physical hardware. Okay, so this is the physical hardware. So on top of the physical hardware, we have a second layer, that is hypervisor. So I will try to duplicate this box. I will take this above and add a text saying this is hypervisor. Okay, there are like multiple hypervisors. I'll try to explain it a bit later. So on top of physical hardware, we have this hypervisor, and on top of the hypervisor, we have the virtual machine. Okay, so I'll draw another box here now. So this is the architecture of the virtual machine, how virtual machines look like. So I'll create another box similar to this. Okay, and in this boxes, we have operating system. So I will try to add text here, OS. Okay, short form. I will create a duplicate and add another operating system. So you see, this is how the architecture look like. So physical hardware, it can be, let's say, a server or your own computer, and on top of the physical hardware you have the hypervisor. So there are like VMware hypervisor, VirtualBox hypervisor, ESXi, vSphere. I mean, there are like so many different hypervisors. Okay, according to the companies, different use cases, but in general this is how the architecture look like. So on top of hypervisor, you can create multiple virtual machines. So this is like one of the virtual machine, and this is like the second virtual machine. Okay, so each VM, as you can see, it has its full operating system. Okay, this is um, not shared. So this is like it has like own virtual machine, own operating system. Sorry. Okay, and each VM consume resources. So this VM consumes some resources, and this VM also consumes some resources. And also it has like own operating system. This will take some time to start. Okay, time taking process. Okay, I will try to write a text box saying here VM1, so that it will be like clear for you as well, and another text box VM2. Okay, so this is how the architecture of the virtual machine look like. Physical hardware, hypervisor, on top of it you have this VM1 and VM2. These have their own operating system. Now let's look at Docker. How does it look like? Okay, I will draw another box. So this is like box number 2 which we have. So in this box, same, I will try to copy this, duplicate, and I will try to paste it text as well. So this is like similar. Let me duplicate this. So on Docker also we have this physical hardware, followed by, on top of it we have like a host OS. Okay, I am going to duplicate this and write it here, and also I'm going to duplicate this text and I will write it here. Okay, so host OS. So you see the difference here. We had physical hardware hypervisor, and here we have physical hardware followed by host OS. Okay, on top of this host OS, I'm going to draw some boxes. So let me take some boxes. This is one of the box. I will try to duplicate these boxes. This is the second box. Okay, I think 2 are enough. So these are like our containers. I will try to give a text as well. Containers. Okay, so containers. So these containers are like sharing the same operating system. So as you can see, there's nothing layer like operating system for the virtual machine. We don't have any let's say separate operating system. So these containers are like sharing the same host operating system. Okay, so they don't need full OS. These containers, they use fewer resources, whereas the virtual machine have like, let's say, separate operating system, more resources. So I will try to write it here, a text, so that it is clear for you as well. More resources are required. Okay, whereas duplicate, less resources because it doesn't have separated operating system. Less resources are required because they are using host OS. Okay, so I will make it smaller so that it will be easier to understand. Followed by the boot time is also fast. Okay, another important point, so I'll write it here. So boot time is fast when compared to operating system, because it is like it has to start up the operating system of the virtual machine. So it is a bit slower when compared to the Docker container. And also the Docker containers are like portable and can run on any system where Docker is installed. So I will try to I won't write everything. Portable and can run on any system. So it doesn't mean it will run on any system. There are some other prerequisites as well, but in general it can run on any system where Docker is installed, and also like the how the application is like built. There are like some other requirements for this, but in general this can be run on other systems as well. Okay, it is portable, easy to run. So when to use virtual machines? There are specific use cases where virtual machines are the better option. For example, running multiple operating system environments. So we have this VM1. For example, I will write it as Linux operating system, and here I will write it as Windows operating system. Okay, if you need to run applications on different operating systems like Linux and Windows, VMs gives you this flexibility. And in terms of full isolation for high security environments where complete OS level isolation is required, VMs provide better isolation. Okay, if you need to run older applications that require specific OS environments, VMs are more suitable. Okay, OS VM1 and VM2, as you can see, different operating systems they are running. So on the other hand, Docker containers shine in specific scenarios. Okay, so these are like different containers, and if you see, these small Docker containers can represent microservices. So Docker is great for microservices architecture, where you break down your app into small independently manageable services. Okay, we can break down. So for example, here I am going to run the front end, and here I'm going to run the database. So I can separate the services very easily without any issues. And also Docker is ideal for automating application deployments in continuous integration and continuous deployments pipelines, because it ensures consistency across environment. Containers start quickly and are lightweight, which makes them perfect for environments that need to scale rapidly. So, I will try to draw some boxes here. So it is very easy to scale up our containers. So one, for example, and so I'll create another real quick. So it is very easy to scale our virtual machines. Containers. Whereas we can scale virtual machines as well, but it's a bit time taking when compared to uh, Docker containers. So in conclusion, so I will try to write a text box here as well, saying virtual machine and Docker container as well on the right side. Docker container. This is like the for differentiation I'm trying to write. So yeah, in conclusion, both virtual machines and Docker have their own strengths, but they are suited to different scenarios. If you need full isolation or are working with legacy applications, VMs are the way to go. If you need faster, lightweight, and portable environments, Docker is more suitable, especially for modern cloud native and microservice architectures. So choose based on your needs. Docker for lightweight, fast, and scalable applications, and VMs for complete OS isolation and flexibility. If you like this video, please don't forget to like, share, and subscribe for more such DevOps tips.